All right, students, today we're going to begin with an entry problem. Please get out your entry sheets. Ms. Seidler, if you wouldn't mind calling, after they're done, calling on two people. Actually, we'll probably just have one person do this one. They are not very long, so one person can do the first and second one. After that's done, if you wouldn't mind having them entertain homework questions, I'll bring up that slide shortly. So if you guys want to pause the recording so you can work on the entry problem, then I'll go to the homework question slide and then we'll get started. Okay, so today we're going to talk about solving inequalities. So solving inequalities is the same as solving equations, except there's one caveat, and this is 2.9a. The caveat is we have to consider what happens when you multiply or divide by a negative. So at this point, all you need to write down is the title, um, wow, that is super messy. Here, let me do this. The title is 2.9a, Solving Inequalities. And I just want to demonstrate something for you before we start writing things down, before you start taking notes. But please take down the title at this point. So look at this. We know that 6 is less than 10. We know that that is true. So we can then consider ourselves adding 2 to both sides. So plus 2, plus 2. And what we get is that 8 is less than 12. 8 is less than 12 is still true. Okay. We can then consider ourselves subtracting 5 from both sides. So if I subtract 5, for example, and subtract 5 from both sides, what I get is, I'm sorry. I'm sorry, I'm so silly. If I subtract 5 from both sides of this one, sorry. If I subtract 5 from both sides of this one, what I get is 1 is less than 5. Well, 1 is less than 5, so that is still true. Then let's consider our original equation. So if we consider our original equation, our original inequality, and we multiply both sides by 2. So I have 6 is less than 10. That's my original equation. And if I multiply both sides by 2, what I get is 12 is less than 20. And 12 is still less than 20. So that is still true. Now if I consider my original equation, 6 is less than 10, and I divide both sides by 2, is the inequality still true? So if I divide both sides by 2, I get 3 is less than 5. Well, 3 is less than 5, so this is true. So what I have shown through doing all of this is that I can add, subtract, multiply, and divide into an inequality, and it doesn't change it from being true. However, is that true for all numbers? Let's try this inequality. -6 is less than -2. I know that to be true because if I consider a number line, here is -6, and here Negative 5, negative 4, negative 3, negative 2. Here's negative 2. Negative 6 is less than negative 2 right here, so that is true. But if I take that and multiply both sides by negative 2, negative 2, and by a negative 2, what I get is 12 is less than 4. Well, 12 is not less than 4. That is a big old false. And what if I take my original equation and I divide both sides by a negative value? Divide by a negative. If I divide, 6 divided by negative 2 is 3, is less than 2 divided by negative 2 is 1. Well, 3 is not less than 1, so that is false as well. So, if I have an inequality that is true, and I multiply by a negative or divide by a negative, I get false statements. Therefore, if you multiply or divide by a negative, you have to switch the sign to make it true. So, if I have 4, if I have 4 is greater than 5, you guys know 4 is greater than 5. If I multiply both sides by negative 3, let's say, times negative 3, what I get is negative 12, and I get negative 15. Well, negative 12 is not greater than negative 15. Oh my gosh. All right, we got to back this up. Undo, undo, undo. Undo, 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 undo. Okay. Start over. 5 is greater than 4. Jeez. Holy guacamole, that was bad. All right. Let's start with the premise that 5 is greater than 4. And let's multiply both sides by a negative. Let's multiply both sides by negative 3. If I multiply both sides by negative 3, I will get negative 15 is greater than negative 12. Well, we know negative 15 is not greater than negative 12. So we have to flip the sign. Negative 15 is less than negative 12. So this is where this rule comes into a play. If you multiply or divide by a negative, you must switch the sign. So notice when I multiplied by negative 3, I had to switch the sign. Because while 5 is greater than 4, negative 15 is not greater than negative 12. Negative 15 is less than negative 12. So I had to switch the sign from a greater than to a less than. All right. So when we're solving, that is what this looks like. If we were solving a normal equation, like the one on the left, negative 8x equals 2, you would just divide both sides by negative 8, and you'd get x equals negative 1/4, because you do have to reduce that fraction there. Easy peasy. But now that we have an inequality, we have to consider the repercussions of working with a negative number. So I'm going to divide by negative 8. So when you in your head say the words divide by negative anything, you have to flip the sign. So these cancel, and I get x is less than negative 1/4. So this is an example of where we have to flip the sign. So I need to flip that sign. That's supposed to be a star. So x is less than negative 4. So if I want to do a graph, here I'm just going to put some tick marks on here. I'll put 0 and then 1 and then -1 just for kicks. Just so I can get a bunch of couple different values here before and after our actual -1/4. So -1/4 goes between 0 and -1. That's where that falls. And so because it's less than and not less than or equal to, I have a parentheses at -1/4 right there. And then I'm going to shade less than. So I'm going to go to the left. Those represent all the quantities less than that amount. So there's my -1/4. And so when I list the interval notation, it's parentheses -infinity to -1/4. And that gets a parenthesis as well because I can't equal -4. So the graph is right here. The interval notation is right here. So we're not going to leave our answer as an inequality. Okay. Here we have 6 is greater than x over 3. So this is x divided by 3. So to undo division, we do multiplication. Or you can think of it as clearing the fraction. So I'm going to multiply both sides by 3. The 3's cancel because 3 divided by 3 is 1. And I get 18 is greater than x. Do I need to clear the sign or switch the sign? No, I do not, because I did not multiply or divide by a negative. You can multiply or divide by a positive all day long. You don't have to switch the sign. But if it's by a negative, you do. Now, however, when I have inequalities, always like to see the x go first. So when I have the x go first, I have to reverse the order of the entire inequality. So x is less than 18. And you can think of it one way. I think of it kind of like as like backing up a train, like you kind of choo-choo it in reverse, and then here it is. And so the arrow has to back up with it, and then the 18 has to back up with it as well. But you could also look at it this way. The alligator is eating the 18, and so when you reverse the order, the alligator still has to eat the 18. So either way you want to consider it. This is just reversing the order of the inequality. Now, when we go to graph it, I'm going to put some numbers before and after 18. So 18, 19, and 17. And x is less than 18, not less than or equal. So I'm going to take a parentheses to denote just that less than. X is less than 18, not less than or equal. And then it's less than, so I'm going to shade left where all the numbers are less than 18. And then have an arrow that denotes it goes to -infinity. So my interval notation is parenthesis -infinity, and I have to have a parenthesis next to the infinity because I cannot reach it. 18, and then end parenthesis. Okay. So here I have to isolate my x. So I'm going to divide both sides by -4. Ding, ding, ding. Dividing by a negative means I have to switch the sign. Oh, didn't switch sign. Gotta switch sign. Gotta listen to my own advice. So I switched the direction of the sign. Now I'm actually going to back the train up, reverse the order of my inequality. So the x comes first, reverse that, and then the 9 goes at the back. And so when I graph it, I'm going to graph -9, -8, and -10. So instead of having a parentheses on -9, I'm going to have a bracket because it can equal -9. And then x is greater than that, so I'm going to shade in the positive direction. So there we go. That's the greater than sign. Also, remember the little trick where the arrow points in the direction you have to shade, it shades to the right. So bracket, because it can equal -9, and then it goes to infinity, and it can never reach infinity. And if you want, you could say positive infinity if you want to be super kind of thorough, but it's really not necessary. All right, so this is your assignment. For this, I will not require a graph, but certainly if you would like to graph to help you create better inequality notations, you're going to have to do interval notation, so using infinities and such, but you won't have to graph. All right, good luck with that, and see you tomorrow.